Now I will be explaining question 5. So the concepts that I'm going to go over in question 5 are weight and inertia. So weight is essentially a force, and a force is equal to mass times acceleration. On Earth, acceleration equals gravity because it's the acceleration due to gravity. So the total weight on Earth is mass times acceleration, or mass times gravity. However, if I'm in space, the total gravity is 0, and so that means the weight is 0. So let's write that down. The next concept I'm going to explain is inertia. The definition of inertia is the resistance of an object to a change in velocity. So basically, inertia is how hard it is to push or pull an object. And essentially, in simple terms, inertia is mass. So now I'm going to read question 5. 2 identical unlabeled boxes are transported to an orbiting space station. The astronauts know that one box is filled with a light sample of ants for an experiment, and the other is filled with heavy tools for repairs. How can the astronauts tell, without opening the boxes, which box has the tools? So ants have very little mass, they're very light, and tools are heavy, so they have lots of mass and they're heavy. So basically I'm going to go through each of the options and explain why it's right or wrong. Okay, so now I will be going over the options. So, option A, weigh each box on a spring scale. The box with the tools will have a higher reading. So, we're going to write A. So, this one makes no sense because, as I said before, the weight in space is equal to 0 because there's no gravity in space. So, this one is incorrect, because weight is equal to 0. So it would never show us the answer. So incorrect. Next option B. Shake each box. The box with the tools will be harder to move back and forth. So this one is correct, and it's because, as we went over before, the concept of inertia. So since, as I said before, inertia is essentially mass, and as we can tell, the tools will definitely have more mass than the ants, so they will have a higher inertia. So this one is correct, and it's because tools have higher inertia. Okay, option C. Push each box. The box with the tools will travel farther before it stops. Okay, so this one is incorrect. It doesn't make any sense, so we're going to write incorrect. Okay, option D. Place each box on opposite sides of a balance. The box on the side that goes down lower will be the box with the tools. So I'm going to draw a balance here. So a balance uses acceleration. The heavier object will accelerate down. However, since, as I said before, we're in space, and in space gravity is equal to 0, this would not help us solve which one has ants and which one has tools. So this is also incorrect. Yes. And then last is E. Toss each box straight up. The box with the tools will go higher before coming back down. So since we are in space, the boxes won't come back down because we're in space and there's no gravity to pull it back down. So this would not show us either. So E is also incorrect because won't go back down. So in conclusion, this problem teaches us two very important concepts. The concept of weight, which is that weight is equal to mass times acceleration. And so, but if we're in space, gravity is equal to 0, so then the total weight is equal to 0. And this problem also teaches us about inertia. And what we learn about inertia is it's an object's resistance to a change in motion, which is essentially mass. And that's how to solve this problem.